Hey folks, Mr. Dell here. We are looking at question asking us whether we have real or imaginary or complex solutions to these equations without actually solving the equations. So let's look at some tricks here or some ideas on how to make this happen. So this is a problem that I'm taking from Math 2, and this is a CPM Curriculum Math 2, and this is section 6.2.3, number 75, 6-75. So it says, without completely solving them, decide which of the following equations have real solutions and which have complex solutions. And remember, complex solutions are the solutions that have an I in it, right? So the standard form of a complex solution is A plus BI. And that I comes from, what does that I come from? That I comes from the square root of a negative number. That's where I comes from. So really, the question is which of these are going to have a negative square root, and that makes it a complex solution. Real solutions just have normal square roots, positive square roots. So if I look at this first one, and I'm not needing to solve it, I can see that if I would have went down the path of solving, I'd have 6 is equal to x squared. Well, I know I'm going to, in order to complete this, I can see I would have to take the square root of both sides, and I would be taking the square root of a positive number. So therefore, these are going to be real solutions, right? Do you see that? So they're going to be real. Square root of 6 would give me some number like 2 point something or other. And I'd have a positive negative out here because when you square root two sides of an equation, you have two solutions, a positive solution and a negative solution. But in this case, it'd be real. But in this one, if I was going to get x squared alone and subtract 6 from both sides, now I have negative 6 is equal to x squared. So if I'm going to finish this one, I would square root, right? But again, here now, I would be square rooting both sides of the equation and square root a negative number. Well, square rooting a negative gives you these imaginary numbers. So these are going to be complex solutions, okay? Let's keep going. Now with this is a little trickier because this one, we've got a full trinomial. You can't just isolate the x squared. You can't just isolate this x squared all by itself, right? You have to use quadratic formula or completing square or factoring. So if I'm using quadratic formula, remember quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a, right? And that's putting it in standard form. The standard form of a quadratic equation is ax squared plus bx plus c. So you would take the a, the b, and the c from your quadratic that is set equal to 0, and then you plug it in. So in short, really all I care about to know if I'm dealing with real or complex is the square root part, because it's the square root part. If the square root part is negative, then it's going to be complex. If the square root's positive, it's going to be real. So I can look at this and see this is remember, this is my A here, right? This is my B, and this is my C. So all I need to do is do the math of B squared minus 4AC for this. So B squared is negative 2 squared minus, and it's 4 times the A, and the A is coefficient of 1, and B is times 10. So I have 4 minus 40. Well, 4 minus 40 is negative 36. So because this is going to become a negative number, I'm going to have a negative inside the square root here. So it's going to be complex again. So my answers are going to be complex. They're going to have an I, an imaginary number. All right. So D. So D, we would do the same thing. D, I'll just get right to the b squared minus 4ac. So we would say b squared, and again, my b here, my c, my a is 1. So negative 2 squared minus 4 times a times c, which is negative 10. So in this case, looks similar to the last question, but now I have a positive 4, and that's minus 4 times 1 times negative 10. So I have a minus times a negative there. That ends up becoming a plus 40. So 44 is what's under the square root. So it's positive, right? So therefore, it's going to be real solutions in this one. Okay. This one here, now, interesting enough, with this one, I can multiply this whole thing out and end up using the b squared minus 4ac. But what's interesting is all of this is squared. So really, I can isolate that and use square root. So if I'm going to add 4 to both sides, I have positive 4 is equal to this x minus 3 all squared. Well, if I'm going to solve this, I'm actually going to, again, square root that to make this x minus 3 now isolate, right? The square root cancels out the squared. And over here, I'd have a positive negative 2. So when I do the math, I don't have a negative square root. So none of my square roots are negative. So these are as well would be real. Last one, we could do the same thing. And I subtract 4 from this side. I end up with negative 4 is equal to x minus 3 all squared. Now, again, if I was going to try to isolate this x minus 3, get it all by itself, the opposite of this squared is to square root all of this. And what you do to one side, you do to the other. But now I'm dealing with a square root of a negative number. So there's going to end up becoming a imaginary component, right? We have plus or minus the square root of 2i. So again, now we have some complex numbers. Okay, there we go.